So let C1 be the circle with the center at point P with coordinates -1 and 1 and with radius square root of 17. And C2 is another circle with the center at point Q with coordinates 1 and -1 and with radius square root of 13. In this problem, we need to determine the equation of each circle, and we also need to find the point of intersection of circles C1 and C2. Before we start solving the problem, let's review the general equation for a circle, which we will use here. So I will write it down: x minus h squared plus y minus k squared is equal to r squared. Here in this equation, h and k is the center of our circle, while r is its radius, So now we will use this general equation to find the equations of circles C1 and C2. Let's start with circle C1. So for circle C1, we have that x plus 1 squared plus y minus 1 squared is equal to square root of 17 squared. Now let's simplify it. So x plus 1 squared is equal to x squared plus 2x plus 1. Y minus 1 squared is equal to y squared minus 2y plus 1, and this whole thing is equal to 17. Again, let's simplify this expression on the left side. So this is x squared plus y squared plus 2x minus 2y plus 2 is equal to 17. Now we will subtract 17 from both parts of our equation, and we will get x squared plus y squared plus 2x minus 2y minus 15 is equal to 0. And this is our final equation of the circle C1. Now let's find the equation of circle C2. Here we will have x minus 1 squared plus y plus 1 squared is equal to square root of 13 squared. Again, let's simplify it. So x minus 1 squared is equal to x squared minus 2x plus 1 plus y squared plus 2y plus 1, and this whole thing is equal to 13. So this expression is the same thing as x squared plus y squared minus 2x plus 2y plus 2, and this is equal to 13. Now we will subtract 13 from both parts of our equation, and we will get that x squared plus y squared minus 2x plus 2y minus 11 is equal to 0. And this is our final equation of the circle C2. Great, now let's do the second part of our problem, where we need to find the points of intersection. So part B. To find the points of intersection, we equate the equations of C1 and C2. So we will write that. So we will rewrite the equation of C1. I will just copy paste it. Here, and we get rid of the right side, which is 0, and we say that it should be equal to the equation of C2. So we will just copy paste the equation of C2. So at the points of intersection where our circles intersect, the left sides of their equations are equal to each other, and now we just need to solve this equation. We see that First of all, we can subtract x squared from both parts of our equation, so we will get rid of x squared. So we can do the same thing with y squared, and we get that 2x minus 2y minus 15 is equal to negative 2x plus 2y minus 11. Now let's move our variables to the one side of equation and numbers to another. So we will have 2x minus 2y plus 2x minus 2y is equal to 15 minus 11. So 4x minus 4y is equal to 4, which means that now we can divide both parts of our equation by 4, and we get that x minus y is equal to 1, which means that x is equal to y plus 1. Now we will put this value in equation C1. So again, I will copy paste equation C1. Copy paste. And we will just substitute x with y plus 1. So we will rewrite this equation as y plus 1 squared plus y squared plus 2y plus 1 minus 2 times y minus 15, and it's equal to 0. Again, let's simplify it. So y plus 1 squared is equal to y squared plus 2y plus 1 plus y squared plus 2y plus 2 minus 2y minus 15 is equal to 0. Let's simplify this. So we get that 2y squared plus 2y plus, so we have 2y plus 2y minus 2y, which is plus 2y, and plus 1 plus 2 minus 15, which is minus 12. And this whole thing is equal to 0. Now we can divide both sides of our equation by 2, and we have that y squared plus y minus 6 is equal to 0. We can rewrite this expression as y squared plus 3y minus 2y minus 6 is equal to 0. And now we will rewrite this part as y times y plus 3, and we will rewrite this part as minus 2 times y plus 3. This whole thing is equal to 0. Now we see that we can combine it as y minus 2 times y plus 3, and it's equal to 0. From this equation we get two solutions. First of all, y can be equal to 2, and second of all, y can be equal to negative 3. If y is equal to 2, then x is equal to y plus 1, so that x is equal to 3. And if y is equal to negative 3, then x again is equal to y plus 1, and it means that x is equal to negative 2. So we get 2 points of intersection. The first point R is 3, 2, so x is 3, y is 2, and the second point, let's call it S, is negative 2, negative 3, so x is negative 2, y is negative 3. And this will be solution to this problem.